A review on advancement in automatic overhead water tank cleaner. Abstract purpose of this paper is to find the solution of cleaning the household water tank used for water storage. The work is done by using two different mechanisms, A. Pinion-Rack system, B. Bar Linkage system. In Pinion-Rack method we use a motor and connect it to a rack. A shaft is connected to the motor and a bar linkage is joined to it. For cleaning the walls of the overhead tank we make use of PVC-made brushes and attach them to the ends of bar linkage, and for cleaning the floor we join a circular disc to the bottom end of the shaft. The disc has some thickness. The bottom and the periphery of the disc is covered with PVC brushes. This setup is designed such that it can fit itself according to the diameter of the water tank. When this whole setup is placed inside the cylindrical overhead water tank and switched on, the motor starts to rotate the shaft, the disc, and bar linkages. The brushes are moved up and down by making use of Pinion-Rack mechanism. Thus cleaning operation is performed. The society is tending towards automation day by day. Cleaning the tank manually is undesirable as it requires lots of time and efforts. So, to solve this problem, this household water tank cleaning system is developed that is more efficient, more safe, less time consumption, and of course no extra human efforts. It doesn't affect the environment and human health in any way. Here a rod having grooves is placed in which brushes are attached through two arms. For rotation of the arms we connect a DC gear motor and a AC motor to main rod. The system also consists of microcontroller and relays for controlling purposes. Keywords: water tank cleaning, cylindrical, bar linkage, motor shaft, rack, and pinion, PVC brush. 1. Introduction. From previous researches and studies it is found, people normally avoid the cleaning of overhead water tank because it is very troubleshooting to clean the tank manually. They have to face various problems, likewise working in the dirty spaces, regular payment problems, use of irritating and harmful chemicals, and so many other reasons. In public sectors like schools, bus stops, railway stations, restaurants and hotels etc., in most of the cases nobody pays attention towards cleaning the tank due to involved extra cost and efforts. Hence this project is very useful for solving all these problems. The problem associated with this project was that people uses different types of overhead water tanks with different dimensions and shapes, but according to a report we found that in India approximate 71% people uses syntax tanks and most of them were 500-liter capacity. So, the project designing of the cleaning machine is adopted by keeping in mind the shape and size of 500-liter syntax tanks. But the job is done in a way that the cleaning mechanism can adjust itself if a little much variations occur the shape and size of the tank. So come to a conclusion by keeping all the problems and needs of cleaning the tank in mind this project is made, that is the solution for all the above problems. 2. Discussion. 2.1 Need of cleaning of water tanks. Water is one of the most important basic need, without which one cannot think of life. According to a survey every person consumes nearly 100 gallons, approximate 455 liters, of water every day. Water is used for brushing, bathing, cleaning, drinking, mopping, and other household jobs. So, for fulfillment of our daily needs, water is stored in cylindrical shaped overhead water tanks for continuous supply. With passage of time these tanks become dirty. Sediments. Algae grows inside the tank and scale starts to deposit on the tank walls. The algae growing in water is so harmful and called algae bloom. These impurities make water unfit for use. Drinking algae-affected water or consuming food can lead to so many diseases, can also affect the liver and nervous system. Bacterial infections may also occur, hence cleaning of the tank is necessary. 2.2 Methods of cleaning. In previous years the cleaning was done by manually scrubbing and rubbing of the tank walls and floor to remove dirt caused by algae and scale. This is the most troubleshooting method of cleaning as it requires more time and extra labor. In some places chemicals are also used for cleaning the tanks. These chemicals are very harmful for the person coming in contact. So, the use of chemicals may also be avoided. In some places pressurized water is sprayed to remove the dirt from the walls of the water tank. But it also requires more efforts and time. To find such an approach that is more efficient and best suited for tank cleaning process, so there is a need to study previous approaches and researches regarding the task. After analyzing so many approaches and researches, conclusion is presented through a summarized table of literature review. 2.3 Proposed approaches. This section of the paper presents the formulation of the identified problem. All the reviews on theoretic approaches are somewhat similar to each other in adopting nearly same technologies. The previously discussed methods are inefficient, more time-taking and requires more human interventions. So, we require a solution to overcome the limitations of previously discussed techniques. Therefore, new designing is developed as per requirements of cleaning. 2.4 Experimental review. In previous years the cleaning was done by scrubbing and rubbing the walls and floors of the tank using manual labor, but this was very time-consuming and troubleshooting method. Due to this, people started to avoid cleaning of the tank. After some time, for ease of proper cleaning, people started to use various high-strength acidic chemicals to clean the tank properly and quickly. Use of chemicals although reduced the human efforts for cleaning, but there were so many harmful effects of chemicals to the person coming in contact. Hence, after watching so many problems associated cleaning of the tank and keeping in mind the importance of cleaning first, mechanical cleaning system was developed by using rack and pinion with PVC brushes, 4 bar linkages and motor. In figure 1, motor is connected to the rack and through rack pinion is attached and a handle is joined to the pinion. With the help of this rack pinion arrangement, the whole cleaning mechanism can be moved up and down. There is a shaft connected to the motor and we join a 4 bar linkage to this shaft. For cleaning the walls of the overhead tank, brushes of PVC are used by attaching them to the 4 bar linkages, and for cleaning the floor we join a circular disc to the bottom end of the shaft. The disc has some thickness. The bottom and the periphery of the disc is covered with PVC brushes. The whole setup is developed in such a way that it can fit itself according to the size of the tank. When this setup is placed inside the cylindrical overhead water tank and switched on, the motor starts to rotate the shaft, the disc, and 4 bar linkages. The brushes are moved up and down with the help of Pinion-Rack mechanism. In this way the cleaning of the tank is performed. Figure 1, Model of rack and pinion method. In another approach, figure 2 of cleaning the overhead water tank, the machine is designed such that a grooved shaft is placed at the center of the tank and that is rotated by an AC motor along with the brushes that are connected through 2 arms to the shaft. The arms make use of compressed spring to adjust themselves according to the size of the tank within its limits. A DC motor is also utilized here to move the brushes horizontally from starting to ending point of the shaft. The bottom end of the shaft is joined to a disc having brushes of PVC at the periphery and bottom surface in order to clean the tank floor. The machine specifications are: A single-phase AC motor, 0.25 HP, 220V, 75 RPM. B. A microcontroller. C. A DC motor, 24V DC. 3. Conclusion and future scope. The most common problem with all the previously discussed approaches is that in all the above methodologies none is completely automation-based system in which no human intervention is required. In all the above approaches the problem of fixing the cleaning mechanism inside the tank occurs. It takes time and efforts that are undesirable. Also, if the dirty water left after cleaning of the water tank reaches inside the water supply pipelines, it chokes the pipes and taps. So, in the modern society that is tending towards complete automation in every field day by day, these types of problems are undesirable. Hence, we decided to work on a project that is complete automation based, in which no human intervention is required. Also, there is no issue of fixing the mechanism manually. There are so many smart features all associated with the cleaning system, such as water level indicator, auto on/off pump, pH level indicator, smart drainage system to avoid blockage of water pipelines and more. Figure 3, showing block diagram of automatic overhead tank cleaning system. In Figure 3 the whole process does not require any effort as it is based on IoT and can be easily controlled by smartphones. It saves lots of time and efforts and also provide more safety and better cleaning and also prevents the losses of water.